Hi guys, welcome back. Fred here, AF Math and Engineering. We're going to do a video for you on single cash flows, okay? So this is the very introductory topic in engineering economics. It's a common course that all engineers have to take, and one of the courses that I've seen a lot of people struggle with, just because it's, not engineering related, and so, a lot of people just think it's hard. Whatever, that's fine. But really, it's not that hard. And if you just learn a few key concepts that I'm going to highlight for you, you're going to do fine in this course. So the first thing that we need to be introduced to, okay, and this is the most simple kind of form of the cash flow diagram, all right, is these two formulas here, okay? And these are the basis that, we're going to get into some different kind of formulas and some different concepts and some harder concepts, but for now, these are kind of the basis of the course. And this is going to give you an idea. So this is a compound interest formula. Okay, so we have F, which is the future value of money, equals the present value of money times this compound interest factor. And on the reverse side, okay, this is just, all we did here is just divide the whole thing by 1 plus I over n to move the P to the other side, essentially. Okay, so P is equals F times the compound interest factor here. And what this does is this is going to give you the future value of money, and this is going to give you the present value of money. So what that means is, for example, on the top one, if I have a present value here that I've invested, what is it worth in 8 years? And this one simply means if I have a future value in 8 years, or if I want, for example, in 8 years to have 8,000, what do I need to invest now? Okay, so those are those two formulas, and we'll probably make a little more sense what I'm talking about exactly when we go into these two problems and you see it applied, okay? So let's get started. Okay, we have a cash flow diagram below, okay? And let's read the question first. If you had $2,000 and invested it at 10%, what would it be worth in 8 years? Okay, so really, really simple. I'm going to show you two ways to solve this, okay? And both you need to be familiar with, okay? So let's take a look. So we have 2,000. Whenever you see in this cash flow diagram, let me tell you guys, the cash flow diagram, being able to navigate the cash flow diagram, knowing how to move along the cash flow diagram and knowing how to draw one. If you can do those things, you've already gotten half of this course correct. I'm telling you, you're going to get 100% on the midterm, because that's very, very, very important if you're comfortable with this. So 2,000 means an investment, okay? So the arrow is down, which means we've temporarily lost money. And at the end of each year, so this is period 0 where we've done the investment, at the end of each period, we're going to gain interest on that at a rate of 10%. It's going to compound every year until we get to n equals 8. So these numbers here represent n in the formula. I is the interest rate. P is the present value. Okay, so where we are on the cash flow diagram now, so we're here on the cash flow diagram at n equals 0. And we're concerned about what the value is at n equals 8, okay? And that is going to be what f is equal to. So we're solving for f. So in this case, we have p, okay, we have I, and we have n, and we want to solve for f, so we're going to use the top formula. Okay, we're going to find the future value. And this is the calculator method of solving it, okay? Next, I'm going to show you the table method of solving it. So let's just use this formula, and this is very basic math. Okay, so we have f equals p times 1 plus I to the n, right? And let's just go ahead and fill that formula in. Okay, so that's equal to p. Okay, our present value is 2,000. And we have 1 plus I. What is our I? Okay, it's 0.1. N is 8. Okay, we have 8 years. And if we go ahead and punch that in, okay, we're going to get a value of $4,287.18. Okay, so in 8 years, if we invest $2,000 now, compounded yearly at the end of each year at 10%, we're at n equals 8, we're going to have a future value of our money of $4,284.18. Perfect. Nice and straightforward. Now, there's another way to do this, okay? And when the formulas get more complicated, and when the cash flow diagrams get more complicated, you're going to need to know how to use the interest tables in your book and that are provided for you. You can't be plugging everything into the formulas because you're going to run out of time. So with that being said, let me go ahead and solve this again. So on the screen, you see you have a table, and what this table is essentially is they've calculated for you at I equals 10. So at the top right, you see 10%. What they've done is they've gone ahead and they've calculated all of the compound interest factors for you. Okay, so the 1 plus I to the n is calculated, and on the left side we have the n values, and on the top going across we have compound amount factor, present worth factor, etc. So really, really straightforward. All we're going to need to do is we're going to find our number of periods here. We're on the right I, we're on the 10% table, so go to n and come down, and we have 8. N equals 8, okay? And then we're going to go across, and we're going to look for the factor that we want, okay? So right now, we're looking for f given p. So f slash p means the f equals p times 1 plus I to the n, which is what we want, okay? And if we go across, we're going to get now, okay, and that factor there is equal to 2.1436, okay? So all we need to do now, okay, is multiply. The notation that we can use here is we're going to say 2,000 times f given p, 10%, 8, okay? And if we sub this in here, and we multiply that, so if we multiply 2.1436 times 2,000, we're going to get 4,287.2 dollars. Okay, so slight difference. As you can see, this one's 4,287.18, and this one we have here is 4,287.2, and that's just a rounding error, probably to do with the table, the interest table. They took maybe a couple less digits of rounding when they did it than the calculator did, but that's fine. Either one would be acceptable. Okay, so that's a really simple start. Let's move on to the second question. You just purchased 100 shares of stock at $60 each. You will sell the stock when its market price has doubled. If the stock price increases at 20% per year, how long will you have to wait to sell? Okay, so let's take a look at what the question's asking. It's asking if the stock price increases at 20% per year, how long will you have to wait to sell? And you want to sell when the market price has doubled. Okay, so we're going to sell when the market price has doubled. So we're starting with a present value of 6,000, and we're waiting until we have a future value of 12,000 before we sell. Okay, we know that it's increasing at a rate of 20% per year, and that's compounded. So how long will it take for our money at 20% per year to increase by double? All right, so that's a good question. So they'll ask you different things, and they might word it a little bit differently. That's why I included the shares of stock. They do like to do that. And, well, how do we solve this? Well, pretty simple. We're going to use the same formula that we used in the first one. Okay, so we have f equals p times 1 plus I to the n. Okay, and let's go ahead and fill this formula in. So we're given our future value of money, so that's 12,000. Okay, we're given our present value of money, that's 6,000. And we have 1 plus I, and we have I, right? That's 0.2 to the n. Okay, so we need to solve for n here. Okay, so n is the value of years that we need. Okay, so how do we do this? Well, this just goes back to basic kind of algebra and calculus. So we're going to divide both sides by 6,000. Okay, and we're going to be given, I'm just going to come down here. Okay, so we have 2 equals 1.2 to the n. Okay, and if we take the log of both sides, okay, so we have log 2, that's going to allow the n to come down. Okay, because when we take the log, we can take the exponent and move it down in front of the log. Okay, so we have n log 1.2, and if we calculate that, so we have log 2 divided by log 1.2. Okay, that's going to give us a value of n equaling 3.8 years. Okay. So it's roughly going to take about 3.8 years at 20% per year for our money to double. So there you go. So, not too difficult. That's just a little bit of an introduction to cash flow diagrams and the basic future and present value of money. So let's do a few more questions in future videos with some more difficult topics, some more difficult cash flow diagrams, and just some more practice in general. Thanks for watching, guys. Like and subscribe.